All right, so let's do some distance, rate, time problems. So in this problem, we read two trains leave the station at the same time, one heading east, the other west. The eastbound train travels at 70 miles per hour. The westbound train travels at 90 miles per hour. How long will it take for the two trains to be 448 miles apart? So on these, I'm reading about distances and speeds or rates and how long things take, times. And so when I'm doing a distance, rate, time problem, I say, da, 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 this looks like a job for dirt. Distance equals rate times time. Okay. So that's going to be the formula that I need. And you know, it's not like you've never used it before. I mean, for example, if you're going 60 miles an hour, if that's your rate, and you do that for 2 hours, you know that you travel 120 miles. So, I mean, it's not totally foreign. Okay. So to proceed, the way I'm going to do this, actually, you know what? I think this will be easier for everybody if I just use their explanation, because there's a lot to write out. So the first thing you want to do is build this cutesy box right here. Okay, so where you have, you know, the distance of both trains, of both scenarios, the time for both, and the speed for both. Okay, and there's always going to be two scenarios. Sometimes the two scenarios are upstream and then downstream. Sometimes the scenarios are with the wind and against the wind. Here it's eastbound and westbound. Those are my two scenarios. So the speed going east, we were told, was 70 miles per hour. That's not a big deal. And the speed for going west is 90 miles an hour. Now, as far as the time, they didn't really tell us. Okay. They just said it's the same amount of time. So we're just going to do that. We're just going to say, well, since I don't know what the time is, I'll call this one X. And if it's the same amount of time, this one has to be X also. Okay. And so, all right, so we got that. And then we said, well, now wait a minute. If you multiplied speed by time, that'll give you your distance. Okay. That'll give you your distance. So 70 times X is 70X. 90 times X is 90X. All righty. So, oh, I'm already at the bottom of the screen. How nice. Okay. So then, now we know that the total distance is 448 miles. At the very end of this whole thing, they're 448 miles away. So the distance for the eastbound train and the distance for the westbound train, when you combine them, it should be 448 miles. All right, so now you just have an equation that you solve. Add them together, get 160x. Divide by both sides by 160, and you get 2.8 hours. So what is that? That's like about 2 hours and 50 minutes or so. 2.75 would be 2 hours and 45 minutes. But that's how it's done. Okay. All right, now let's do one of these. The good news is that it's a word problem. Yeehaw. Okay. The even better news is that on these Pythagorean Theorem word problems, they always give you the picture. So to be honest, you don't even really have to read the problem, although it's a good idea just in case they try to slip one past the goalie. So we got a 34-meter tall building. Again, a meter is about a yard, a little bigger than a yard. The distance from the top of the building to the tip of the shadow is 37 meters, just like in the picture. Find the length of the shadow, along the ground. So we need to use the Pythagorean theorem. So the Pythagorean theorem is a squared plus b squared equals c squared. In case you had forgotten, and since I'm sure you don't use this in everyday conversation, it's quite possible that you have forgotten. Okay, and A and B, they are the two sides that form the 90-degree angle. Okay, and they're interchangeable, doesn't matter. C is the other side, the side that does not form the 90-degree angle. It is called the hypotenuse, and it is always the longest side, side C. Okay, so, well, we know that A is 34, and B is what we're looking for, and C is 37. So, square some of those things out, and we get 1156 plus B squared is 1369. All right, if I subtract 1156 from both sides, I get 213. Then I shift into take the square root mode. Okay. That's going to give me 14 point, let's see, it says nearest 10. So 14.6. 14.6 what? This is a word problem. It has context, so I need to include my units. 14.6 meters. And then that, that's it. Okay. And they're all done very, very similarly. Just make sure you put, at the beginning of the problem, make sure you put the numbers in the right spots. Okay. Now on this one, there is one key word here, and it is all. When it just says find the square root, like find the square root of 81, you would say 9. Okay. And why is 9 the square root? Well, because if you square the 9, you get back to what you started with, 81. That's one way of looking at it. But this one says find all square roots. Well, isn't it true that -9, when squared, also gives you 81? If you square it correctly. Okay. So, some people, they go to their calculator and then they say, all right, -9 squared is not 81. I said, well, that's because you didn't square -9. You squared the 9 only, and then the negative sign got tacked on at the end because of order of operations. So if you make sure that you square the entire number, yeah, you get back to 81. Okay. Therefore, -9 is also a square root, just like +9 is. So when they say all square roots, they mean the positive and the negative answer. So they want 9 and -9. And let's do one more of those. Maybe one more than that. So the square root of -4, there is no real number square root of -4, because, if you say, well, the answer is 2, well, if you square 2, do you get back to -4? Nope. If you square -2, do you get back to -4? Nope, just like we saw in the calculator. So for this one, the answer would be none. There are no real number solutions. Okay, how about another one we haven't already done? There we go. So this one, the square root of 100 would be +10 and -10. It would be both. Okay, so here's a new topic. Once again, I'm just going to use what Alex has for the explanation. So a couple of different problems here. So for the first one, square root of -5 to the 4th, if I write that out as 4 -5s under the square root, then maybe that's too small. I don't know. Then they multiply to +625. The square root of 625 is 25. Okay, so even though there were negatives in there, the order of operations says simplify inside the radical first to get that 625. Then work with that square root. And something very similar here, square the -9. Actually, it's getting too small to write down there. So I would say, let's evaluate inside the square root. -9 squared is positive 81, and the square root of 81 is 9. They're not asking for all square roots, so we're just going to do the principal square root, or the positive one. And that's kind of how it goes. So simplify inside the radical first. Okay, so how do we simplify this one? Well, we know the square root of 64 is 8. Okay. Now we still have to handle the w's, but why is the square root of 64 8? Well, one explanation I gave just a few moments ago in this video is because if you square 8, that gets you back to the 64. Okay, another way of looking at it is to say, well, when you're doing the square root, you're looking for pairs of things that when multiplied together, well, you're looking for pairs of things multiplied together that give you what you had. Well, 64 is 8 times 8. That's 2 8s. So that means that I can pull out a group of 8s right there. Now, I also have 8 w's. 4, 5, 6, 7, 8. Now, hopefully you'll get the hang of this quickly so you don't have to write this out every time. Okay. By the same token, I can say, well, hey, here's a pair of w's. So I get that. Here's another pair of, oh, wait a minute, I can do different colors. That'd be fun. Here's another pair of w's, so I can do that. Here's another pair of w's, so I can do that. And here is, I don't want that color. And here is another pair of w's, I can do that. So that my answer is 8w to the 4th. Okay. And that's how it goes. So with square root, you're looking for pairs of things that are the same, that multiply together. And then every pair can come out. Okay. So let's see an alternative way of doing that might be a little faster. Okay. I could say, well, w to the 8th is w to the 4th times w to the 4th. And then, which it is, and then, hey, look, I've got a group of 2 things that are the same. So I could write it like that. So in other words, basically I've given you the reason why when you're doing square root of a variable to a power, in the answer is always half of the original power. So yeah, that's how it goes. Let's look at another one here real quick. Hopefully it'll be different. Not enough. I want more different. There, that'll be differenter enough for. Okay. So the square root of 16 is 4, and half of this 16 here is 8. And we can always check that on the calculator. We can plug in the original expression, plug in our final, and see if they match. So I'm going to do that. So I'll go square root of 16 x to the 16th. And supposedly that's supposed to be equal to 4x to the 8th. And they're supposed to match. If I go to the table, and look at that. Doesn't matter what the x value is that I'm plugging in, they match, they match, they match. They match everywhere. Therefore, they must be the same polynomial because they're responding the same way to every x value that I plug in.